You have 9 balls that are all identical, but one of the balls has a slightly greater mass than others. You have a balance that you can use for weighings. Using the balance for ones would be counted as one weighing. So what is the minimum amount of weighings required to take the odd ball out? So you have 9 different balls. They all look the same though, and one of the balls has a slightly greater mass than others. And you have a balance that you can use in order to check out which one of the ball is heavier. And if you use it for once, it will be counted as one weighing. If you use it for 2 times, it will be counted as 2 weighings, and so on. So I encourage you to pause the video, and when you're done thinking about the problem a bit, you can come back to see the solution. I assume you had a try at it, so let me first of all highlight any of the balls right here. For example, I just highlight the ball number 7, and I considered this to be the heavier ball. It does not necessarily has to be ball number 7. It can be any of the 9 balls, right? So I just did ball number 7 for the sake of simplicity and your understanding, and moving on. And then what I need to do is that I need to draw a slightly, well, that's not slightly, a slightly greater version of the balance that I have just drawn above. And then I need to do is that I need to make 3 different sets of these balls here, and I mentioned this set A, this B, and this set C. Now, according to our scenario in which the heavier ball is in the set C, what I need to do is that I need to put any of these 2 sets here. I could just put A and B here and C outside, or it could be other way around. I could have put just C here and B here outside, any way you like. Now, in this scenario, there are 3 things possible. Either side A is going to go down, or C, or is it going to, or is it is just going to stay balanced, right? So now you need to observe what happens here. As I mentioned, the heavier ball is present in set C, for example, then set C is going to go down this way. The equilibrium is going to shift this way, right? Because the heavier ball is present in set C. However, if the set B was here and C was outside here, then it wouldn't turn this way. Instead, it would just stay balanced. And if it stayed balanced, you would know that heavier ball is neither present in A nor in B, but it is present in set C, right? So on this, in this weighing, you're able to eliminate 6 of the balls that it is not present in A, not in B, but in set C. And then in the next weighing, what you need to do is that you're left with 3 balls, those of set C. This is set C, right? This is ball number, for example, 7, 8, and 9. And as I mentioned, ball number 7 was the heavier. Now what you need to do is that, now the rest is, although the procedure is same, but you can see the sense is getting made. You just need to put 1 ball here and 1 ball here and the 3rd ball outside, right? So this could be ball number 7, 8, and 9, or this could be 9, 8, and 7. It doesn't even matter, because the same thing is going to happen again. This is going to go down if this is ball number 7. If this is ball number 7, then this side is going to go down. If ball number 7 is this, then neither side will go down, but it'll stay balanced like this because they have the same weight. So ball number 7 will be outside. And if this is not ball number 7, for example, this is ball number 9, this was 7 and this was 8, then this will go down this way. So in the second weighing, you figure out that ball number 7, or you just actually pick out the ball that was heavier. So it only required 2 weighings. So did you figure it out? This is what game theory is about, that you need to make a procedure and strategize your working in order to obtain the answer in the most efficient way. And I'll be coming up with more game theory videos in future, and I hope you like them. Thank you for watching.